Let's see the definition of locus of a point. A locus of the point definition is the path traced out by the set of points under certain conditions is called the locus of the point. So the certain conditions also we can call it as the geometrical law. So the path traced out by a set of points under some geometrical law or some conditions is called the locus of the point. So let us move on to the example. So let us consider one clock, and you take, this is a minute hand of the clock, and let's observe its path. So how it is moving? It's moving like this. Okay, so it's moving like in this path it's moving, and again you come back to the same position here. So now you see, by joining these points we can get a one geometrical shape. What is this geometrical shape? This is familiar for us. This is nothing but a circle. So you see, the path observed by the set of points under some condition. Here the distance is common, fixed distance. Suppose we can take this length of this minute hand is d. So from the center, some one point we can take, this is the point P, we can take it as a locus. So from the distance, fixed distance, the point P is moving like this. So by joining all these points we are getting one path. This path is called the locus of the path. So here the locus is circle. So we come to the second example. Suppose you are in your home and we have to go to a park. So nearby you are having one park nearby your home. So just we have to go. So this is the road towards the park. So this is the road going towards the park from your home. This is your home. So you see, you want to go to the park by this way. So you can go by like using by walk or by car or by cycle, somewhere you can go like this. So you are getting the points like this. So just you connecting all or joining these points, we are getting one path. This path is called the locus. Okay, this path represents the locus. Let's move on to the mathematical example. Example number 3. So let us consider 2 points P and Q. So let us consider 2 points P and Q. So let us take this point as P and this point is Q. So we can join this point, and this is the line segment PQ. Now the question is, the point which is equidistant from these 2 points P and Q are the locus of the point which is equidistant from these 2 points P and Q. So how can you find the equidistance? Means, you see, this is the point P, this is the point Q. So equidistance means definitely we can take the center. The center one, definitely it will, the center point is definitely equidistant from both the points. So similarly, how many points we can find? There are infinitely many points we can find it for this case. So here you see, here similarly we can take this point as equidistant from these 2 points, and this point is equidistant from these 2 points. This point likewise it will go. Similarly this side also will come like this. So by joining all these points, we may get one straight line. We are getting one straight line by joining all this. So you see, this is the perpendicular bisector to this line. Okay, so here you see the set of points, these are the set of points. The path traced out by these points is called the locus of this. Okay, so here the locus of the point which is equidistant from the 2 points P and Q is the perpendicular bisector. Okay, this is one example. Let's move on to the another example, the mathematical example number 4. Let us consider 2 axes, that is OX as well as OY. So these 2 represents the axis OX and OY. The question is, the locus of the point which is equidistant from these 2 lines or these 2 axes. So how can you find these? So let us take, suppose we are finding one point here, means this is equidistant from this line as well as this line. Similarly, if you are putting a point here, this point is equidistant from here and here. Similarly, we can find out, we can draw a line. So we will, by joining all this, we will get a line like this. So you see, now this is the path traced out by the set of points which satisfies the condition. What is the condition? Here the the point is equidistant from the two axes. Okay, so now this line is nothing but the angle bisector of the angle made by XOY. Okay, this is the angle bisector of the angle which is made by the OX and OY line, and also it is called as the locus of this point. So now let us move back to the definition. So the path traced out by the set of points, the path traced out by the set of points under certain condition. So here is the path traced out by the set of points, here the set of points, here also the set of points. So the path traced out by the set of points, and here the path traced out by the set of points, here the path traced out by the set of points, and here the path traced out by the set of points is called the locus of the point. So from this we can understand that the locus may be a straight line, or locus may be a curve, or locus may be a circle, or locus may be any geometrical figure.